In this first problem, zinc and excess hydrochloric acid react to produce zinc chloride and hydrogen gas. If 0.289 moles of zinc were used, how many moles of zinc chloride would be produced? The first thing we always do is write a balanced equation. Zinc, Zn, plus hydrochloric acid, HCl, yield zinc chloride, ZnCl2, plus hydrogen gas, H2. We then have to balance this equation. Since there are 2 hydrogens and 2 chlorines on the right-hand side, we need to put a 2 out in front of the HCl. The equation is now balanced, and we can fill in 1s as the coefficients in front of all of the other substances. In this problem, we were given 0.289 moles of zinc, and we were asked to find the moles of zinc chloride. If you're following along on your mole roadmap, this would be going from moles of A to moles of B. We put our starting number out in front, 0.289 moles of zinc, and we multiply that times the units that we have going on the bottom over the units that we want. Then we look at the coefficients and we plug those in. The coefficient in front of ZnCl2 is 1. The coefficient in front of Zn is also 1. Now we can do this math. 0.289 moles of zinc times 1 divided by 1 is 0.289 moles of ZnCl2. In the second problem, sodium chloride decomposes into sodium and chlorine gas. If 9.45 grams of sodium chloride were used, how many grams of chlorine gas should be produced? Again, we start by writing a balanced equation. NaCl is decomposed into Na and Cl2. To balance this equation, we have 2 chlorines on the right-hand side, so we need to put a 2 out in front of the NaCl, which gives us 2 Na's, so we have to put a 2 in front of the Na, and now we should be balanced, so we can fill in a 1 in front of the Cl2. In this problem, we were given 9.45 grams of sodium chloride and asked how much chlorine gas should be produced. If you're following along in your mole roadmap, this would be going from grams of A to moles of A to moles of B to grams of B. So we start by putting our 9.45 grams out in front of the NaCl. First, we're going to multiply it times the molar mass on the bottom and 1 mole of NaCl on top. When you add up NaCl off the periodic table, you get about 58.5 grams. Then we have to go from moles of NaCl to moles of Cl2. And to fill in those numbers, we use the coefficients. There's a 2 in front of the NaCl and a 1 in front of the Cl2. And then our final step is to change it from moles of Cl2 into grams of Cl2. And then for these, we plug in 1 mole for the Cl2, and then we have to plug in the molar mass of Cl2. So when you add that up off the periodic table, you get about 71 grams. Now we can do the math. 9.45 times 1 divided by 58.5 times 1 divided by 2 times 71 divided by 1, and we get a final answer of 5.75 grams of Cl2.